Assalamualaikum warahmatullahi wabarakatuh, and hi everyone from International Postgraduate Conference on Engineering, Science and Technology, CAS 2017. I am Siti Norafida binti Jusoh and from University Technology Malaysia, Johor Bahru, Malaysia. Today I would like to present a 3D numerical model of soil tunnel interaction induced by segment joint parameter. So, as we know that tunnel lining is not similar to a common construction design, which usually a building will be looked for ultimate limit state design. But tunnel lining is more on surface ability because tunnel interact with soil and it acts as a tunnel support, the support system, but in the same time have to allow the deformation and also have to incorporate soil stress redistribution. So that's why segments lining are lined together with a joint, not as a full ring continuous tunnel, but split into a few segments tunnel lining, and a few segment tunnel lining connected with the joint form a one tunnels ring. So this is especially exists in the tunnel boring machine type. So we can see that we have a rings to rings, ring to another ring joint that called circumferential joints, or simply called rings joint. And another one is segment to segments longitudinal joints. Not forget to mention, we also have packers in the tunnel to fill the voids. And in this presentation, I would like to highlight the segments joint discussion. How the segments joint affect the tunnel overall behavior. So large deformation can be often accommodated by the tunnel lining, either by rotation or shear. This will induce high stress. So we would like to the tunnel lining design is an interactive problem because we want to allow the movement, but we want to reduce the stress or bending moment. So joint is there to ensure that tunnel is capable to resist movement and at the same time to allow movement. Clappers have stated that joints will highly affect the tunnel global behavior results. And segments joint is very crucial to be investigated, but complex to be fulfilled due to the curve shape and so on. So today, hoping that the numerical modeling is used to enhance analysis in order to optimize the design of lining and tunnel in overall. And by the end of the presentation, I'm hoping that I can show you how the numerical model helps to understand the structural response of induced by the soil tunnel interaction, and in the same time also to observe the deformation that induced due to the tunnel excavation process. So this numerical modeling has been divided into three different phases. Firstly, a segment to segment with the joints model, joint parameter model, and extended into full ring tunnel model that embedded into full soil tunnel model. So for the segments joint model, this is the material properties that has been assigned. We can see that we provide 2 points to include the segments joint parameter model. So later on, I will show you the parameters model of segment. So for 3D model of soil tunnel modeling, I have adapted Circle Line Stage 3 of Serangoon Interchange Station of Singapore, which using the fast track tunnel modeling method or all at once tunnel method that proposed earlier by Vermeer and Moller. So the soil model adopted a more Coulomb criterion model with a cohesion value of 1 kilopascal to avoid divergence in analysis. And not to forget, the groundwater table was introduced at 2.5 follow the real situation of the case study. So this is how the soil block model is shown. Model. So we can see that tunnel is located at 25 meters from the ground surface. All the soil model, periphery of the soil model were assigned with the boundary condition together with at the bottom of the soil. So this is the soil properties, and interaction model has been assigned. For segment to segment model, parametric study has been carried out with a spring tie. Tie is represent the continuous tunnel, means that tunnel without segment. And hinge interaction model can be assigned with a different stiffness. So I have tried H rigid, H with a 1 kilopascal and 1 megapascal, and also hinge nonlinear. Hinge nonlinear, the data is taken from the laboratory test data. So another one is ring to ring joint, and another one, the last and important one is soil tunnel interaction, the master slave surface to surface soil tunnel interaction model. And I also carried out another soil block model, simplified one, 4 layers only compared to 7 layers earlier, with 19 rings, not all in one method but standalone ring methods. So the results show, of course, we can see that obviously at the crown of the tunnel lining is distorted quite badly, and the ground surface also affected at the large area due to the tunnel excavation. So in the longitudinal settlement, you can see that this is a hinge model, the orange one, with all at once modeling. This is with the 19 rings standalone. This is a tie model of segment joints tie model. The existing data is from settlement marker and also the fiber optics. Although the finite element model doesn't resemble exactly like the pattern that measured at the field, because steady state only occurred at the middle parts and doesn't have a sudden drop, but the results is obey the Gauss Pact 1969 suggestion of the longitudinal settlement standard curve. So we can see that 19 rings result with hinge segments joint is much more resemble to the ground field data, and tie is showing different or not very good results. So as a conclusion, we can say that numerical modeling has simulated the laboratory experiment and case study and help us to understand the structural response in general, and also the deformation or the ground settlement. And in this presentation, I have embedded a few different segments joint, and the effect of joint, different joints show different pattern of the results. And in general, result shows compression strain measured at the extradus and tensile strain measured at the intradus of the segment tunnel lining. And the distortion occurred highly at the crown. And hinge with nonlinear angular joint stiffness properties H and L have showed the closest moment response to the dual jointed segment. And the ground deformation, the settlement throw were measured. The longitudinal settlement has been measured, and we can see that flexible segment joint induce a smaller flexural bending moment, and resemble ground settlement compared to the tie constraint or continuous joint segment joint model. So I think that's all for my presentation. See you again, and Assalamualaikum warahmatullahi wabarakatuh.